Hello everybody. So this video is called Parts of a Wave. You have watched a video of a water wave already where something was dropped into water and it made little ripples in the water. If you took a side view of those ripples, it would look something like this right here. Little waves going up and down and up and down. There's high parts and low parts. And what that's caused by is you could see when something was dropped into water, the wave moved left to right, or right to left. Either way, it moved to the side, not up and down. All right, it propagated out of the center spot where the object was dropped, and then it spread left to right, horizontally, in other words. But what each water molecule is actually doing, here's this little dot we drew, is a water molecule. Right here. The water molecules are actually going up and down like a rubber ducky in the water, okay? It would do if you took a side view of it, see it going up and down. Alright, so the medium, the water that is transmitting the wave is actually doing up and down motion while the wave moves horizontally. So there is a right angle between the way the water is moving and the way the wave is moving. Alright, so you draw that little picture up there first, and then flip this over. Continue our notes on this side. Don't forget to give yourself a date today and title it up Parts of a Wave. You can pause if you need to. So here's a picture. You could pause and write this down as well, okay? And then restart it, all right? Okay, so we're back, all right? Now, with this picture here, this is a picture of one wave, okay? Or one cycle of a wave, okay? We call it one wave because if you take this shape and you keep repeating it over and over and over, you get that nice side view of a water wave that we saw before, okay? So one wave consists of two parts, actually. The crest, kind of like when a wave is cresting, it's the top of the wave right there. This part right here is the crest. The crest is half of a wave, so if you just have a crest, you only have half of a wave. Because it's not the full cycle. Because all cycles that cause a wave have a crest and what we call a trough. T-R-U-G-H. And that is, in real life, it's something that pigs eat out of. And it's shaped kind of like that. Alright? So that is sort of like the crest, but on the opposite side, okay? And when you put those two together, you get one full cycle, and we call that cycle one wave. Alright? Crest is half of a wave, trough is half of a wave. Together, they are one cycle or one wave. There's also this dotted line that goes through the center, and that's called the line of equilibrium. And what that represents is, if there wasn't a wave moving through this water, that would be what the water level looks like, right at that dotted line. It's called the line of equilibrium. Okay? Next thing we need to look at is how do we measure the length of a wave? How long is this wave? Well, the wavelength is what we're talking about then. So the wavelength is the length of one wave, or one cycle, in other words. Alright? There's a Greek symbol we use to represent wavelength. It's called lambda. This Greek symbol, it looks like an R. I could kind of show you how it works. It's like a slanty line, and then this little curvy line here, okay? And if you want to Google what it looks like, if you don't think my artistic rendition is good, it's spelled L-A-M-B-D-A, lambda. Alright? So that is the variable we use, like x or y. You know, we use lambda instead to represent wavelength, the length of one wave. So write this down too. One wave or cycle is a crest and a trough together. So when you have a crest and a trough together, the length of those two together is the wavelength. Let's look at the picture. All right. Here is lambda again. Make it, there's a nice lambda. There's lambda again. That's wavelength. So the wavelength it starts over here at the beginning of the crest and goes to the end of the trough. Okay? So this whole green line, starting here to here, is the wavelength. Right? The length of one wave. One more term you're going to need to know. Still have to write this one down. So you write it down too. It's called the amplitude. It's represented with a capital A, and it's the height of the wave. There are two ways to measure amplitude. The first way is from the line of equilibrium to the top of the crest. That's a good way to measure amplitude. Another way to measure amplitude is from the line of equilibrium, and it should be the same distance down to the bottom of the trough. So if you go from the bottom of the trough to the top of the crest, that's actually not the amplitude. It's just from the middle down or middle up. Okay? That's the amplitude. That word might be familiar because amplitude might sound like amplifier used in music to make music louder, right? So you plug your guitar into an amplifier to make music louder, and the energy from the electricity in the wall is added to the energy you create from sound and creates a louder, more energetic sound. That's what energy is with sound. It's the loudness of sound, okay? So a higher amplitude wave, if it's a sound wave, would just be a louder wave, okay? So it's going to come in handy when we study volume later on. Okay. Let's turn this over one more time. You copied this already up there, but now we're going to copy these examples. Pause it and copy the examples real quick. All right, now let's solve the examples together. You should have the pictures drawn, and letter A and B for each example are the questions you're going to be asked. All right, so what do they show us in example 1? They give us a picture with a crest, a trough, and another crest. And the whole picture from left to right, they're telling us, is 9 meters long. They're not saying that's the wavelength necessarily. They're just saying this crest, trough, and another crest all together, left to right, is 9 meters long, okay? Our first question is, how many waves are in this picture? Well, we know one wave. What is one wave? It's how do we measure that? It's a crest and a trough together. That's one wave. So a crest by itself is only a half of a wave. A trough by itself is only half of a wave. So this is a half of a wave. Here's another half of a wave. That's 2 halves. It's actually 3 halves now, because we added another crest in that picture. So this picture is half a wave, half a wave, half a wave. It's 3 half a waves, or in other words, 1.5 waves would be your answer to A. Okay? It's 1.5 waves. I like to count half waves and just add them up. I got 3 half waves, so that is 1.5 waves. because this one isn't really complete, you know, if we had to add another trough to complete it. Anyway, so the wavelength, let's ask that question. What is the wavelength? So the wavelength is the length of just one wave. 9 meters is the length of, well, we just said it's the length of 1.5 waves. But wavelength, they're asking what's the length of one wave in that picture, all right? So, the wavelength, all right, length of a crest and a trough together. What I like to do is to first measure how long just a crest is, and then figure out the wavelength. So if you look at this, there's 3 parts here. 1, 2, 3. 2 crests and a trough. 3 parts. The 3 parts are 9 meters long. I'm going to erase these little halves here for some more room. The 3 parts are 9 meters long. So each of the parts is only 3 meters long, because 9 divided by 3 gets us 3. So if you divide 9 by 3, you figure out that each part is just 3 meters long. But the wavelength is not just the length of a crest, which is 3, we just wrote it. It's the length of a crest and a trough together. So 3 and another 3, all right? So the wavelength here is 6 meters. So the wavelength, I really find that there's 2 steps to solve for the wavelength. First, you find the length of a crest, and then essentially you just double that number, and you have the length of the crest and the trough combined, all right? So now let's do the second example. Just another one for practice, okay? We have crest, trough, crest, trough. 4 parts altogether. Those 4 parts are 20 meters long. So how many waves are there? Well, one wave, remember, is a crest and a trough together, okay? So those 2 together are 1 wave, and those 2 together are 1 wave. So all combined, we have 2 waves. Now what is the wavelength? It's the length of 1 wave. Length of a, remember, crest and trough together. So remember our 2-step strategy for finding wavelength. Find the length of each of these 4 parts. First, you could do 20 divided by 4, and that gives you the length of each of these parts is 5. But 5 is not the wavelength. 5 is just the length of 1 crest by itself or 1 trough by itself. But a crest and a trough together is what gets us the wavelength. So 5 and 5 make 10. And that is the length of a crest and a trough together. That's the length of a whole cycle or a whole wave. Alright guys, if you don't, I try to work through this here, but feel free to call us over if you didn't really understand these examples and ask us some questions, alright? Or G-chat us, definitely, because you're going to have a Canvas quiz on this coming up.